This is Module 11, Section 6.2. In this section, we're going to look at factoring x squared plus bx plus c type trinomials. Many trinomials factor as the product of two binomials. Basically, it's the FOIL method in reverse. In Section 6.2 and 6.4, we will discuss two different types of trinomials, the x squared plus bx plus c type and ax squared plus bx plus c type, where a does not equal 1. If a is equal to 1, then you have the first type, x squared plus bx plus c. For the x squared plus bx plus c type, we simply need to find factors of c that add to give us b. These factors will be the last terms in our binomial groups. The first terms in each binomial group will simply be the factors of our first variable term. So for example, notice that this trinomial, you know it's a trinomial because it has three terms. Remember, terms are separated by addition or subtraction. This is a basic x squared plus bx plus c trinomial, and the quick way to recognize it is notice that there is no coefficient written in front of the x squared term except for an understood 1. All right, so for x squared plus bx plus c, the b simply represents the number or the coefficient in front of the x, and the c simply represents the number at the end of the polynomial, in this case a positive 6. So for this example, b is equal to a positive 5 and c is a positive 6. Okay, to factor this easier trinomial, what we're interested in doing is finding factors of c that when you add them give you whatever b is in your problem. Okay? Now remember, factoring is a division problem, and so for this problem we want to find factors of positive 6, because that's what our c is, that when we add them instead of multiply them, give us our b term, which is positive 5 in this example. So let's look at factors of 6. Sign is important, and if you wanted to find all the possible factors of positive 6, one example would be positive 1 times positive 6. 1 times 6 is 6. Or positive 2 times positive 3. 2 times 3 is a positive 6. Or negative 1 times negative 6. Negative times negative is a positive. Or negative 2 times negative 3. That product also gives you a positive 6. So here's what you want to ask yourself. Of those 4 factorizations, all of them, when you multiply them, give you positive 6. Are there any, when you add them, add to give you a positive 5? And let's look at this first example. 1 times 6 is 6. 1 plus 6 is 7. But that's not what we want. We want a positive 5. So that's not the factoring we want. Let's look at this second example. 2 times 3 is 6. 2 plus 3 is positive 5. This is it. Okay? So the factor that we're interested in is positive 2 and positive 3. For these easier trinomials, these are going to factor into two binomial groups. The two factors we just found, positive 2 and positive 3, end up being the last factors in each group. Positive 2 and positive 3. What goes in the first group of each group is the factorization of your first term. Now if you think about breaking down x squared into nice, pretty factors, really the only way that you're going to break down x squared is x times x. Remember, you add the exponents. 1 plus 1 is 2. So x squared only breaks down to give you x times x in factored form. And so positive x and positive x go into the first group. And that is the factored form of x squared plus 5x plus 6. And you could check that if you wanted to by FOILing it out or using distributive property. or using one of the other methods we talked about in a previous module, if you FOIL that out, okay, FOIL, F stands for first two multiplied together. So x times x is x squared. This is our check. Outer product would be x times plus 3, which is plus 3x. Inner product would be positive 2 times x, or plus 2x. And last two, positive 2 times positive 3 is positive 6. Combine like terms, and you get x squared plus 5x plus 6. This is a check, so is this the same as our original problem? And the answer is yes. It checks, looks good. Our factoring is correct. Okay, so let's do some more examples. Okay? Recognize that although in general ax squared plus bx plus c, or in this case this is our x squared plus bx plus c example, because there's no number in front of the squared term other than an understood 1. Okay? Recognize that they don't have to be x's. They could be y's or they could be a's. Any variable, method is the same. So in this case, our b value is a negative 7, and our c value is a positive 12. Make sure you carry the sign. Sign is important. Okay, to solve this, we want factors of c, which in this case is factors of positive 12, that when we add them instead of multiply, we want to get our b term, which in this example is negative 7. So how many different ways can we break down positive 12? One possibility would be positive 1 times positive 12, or positive 2 times positive 6, or positive 3 times positive 4, or, now those are all the double positive possibilities. We could also look at all the double negative possibilities. We've got negative 1 and negative 12. We've got negative 2 and negative 6. And we've got negative 3 and negative 4. All of those products give you a positive 12. Now, of those 6 possibilities, is there one set of factors that when you add instead of multiply, give you a negative 7? And the answer is yes. It happens to be the very last possibility I wrote down. Negative 3 times negative 4 is positive 12, but negative 3 plus negative 4 adds to give you negative 7. So these are our factors, negative 3 and negative 4. So where those go in your factored form is that's the last term in each group. Negative 3 and negative 4. What goes in your first position is the breakdown of your variable term. Okay? Y squared, the only way you're going to break that down is y times y, and that is your factored answer for that problem. And certainly, as before, you could check that if you wanted to by foiling it, or you could use one of the other methods we talked about. Just as a little bit of review, let's say you wanted to use the area method to multiply it out and check it. Remember, what you have here is rows and columns. So for our rows, we've got a positive y and a negative 3 as our label. For our columns, we've got a positive y and a negative 4 for our label. Then remember that what goes in each of those area boxes is the length times width product of that rectangle. So y times y is y squared. Here, y times negative 4 is negative 4y. Down in our lower left, negative 3 times y is negative 3y. And in our lower right, negative 3 times negative 4 is a positive 12. You've got some like terms to combine. If we put all that together, we've got y squared. Minus 3 and minus 4 is minus 7y. And then plus 12. And since this is a check, this should be the same as our original problem. Y squared minus 7y plus 12. Looks good, which makes me confident that our factoring was correct. All right, let's look at this problem here. Remember that b is the number in front of your x, c is the constant at the end, so we want factors of c, or factors of positive 20, that when you add them, give you your middle b term, which in this example is positive 9. So there's a variety of ways you can break down 20. You've got 1 times 20, or 2 times 10. 3 doesn't go into 20, but 4 does. 4 times 5. And then the next positive factor would be 5, but we've already taken care of it. Now, if that's positive, there's double negatives also of all those factors. So negative 1 and negative 20, negative 2 and negative 10, and negative 4 and negative 5. Of those 6 examples, hopefully one of them adds to give us positive 9, and it does. 4 plus 5 does equal 9. So our factors are positive 4 and positive 5. So if we come up here and write our binomial groups, we've got positive 4, positive 5. The x squared breaks down to x times x, and that's the factored form of x squared plus 9x plus 20. And you could check that if you so choose. All right, y squared plus 3y minus 40. We want to find factors of c, which is negative 40. Make sure you carry the sign. That when we add them, give us our middle term, which is positive 3. Now, negative 40, you want to be careful here because there's a lot of possibilities when your number is negative. You've got positive 1 times negative 40. 1 times negative 40 is negative 40. And also, negative 1 times positive 40. Those are 2 different possibilities. Okay? And when you add those are going to give you 2 different numbers. Okay? We've also got positive 2 and negative 20, or negative 2 and positive 20. Multiply to give us negative 40. We've got, let's see, 4 times negative 10, or negative 4 times positive 10. That gives us negative 40. We've got positive 5 times negative 8, or negative 8 times positive 5. Oh, sorry, that's the same. Let me try that again. 5 times negative 8, or negative 5 times positive 8. And we could continue on looking for all possible factors, but your goal is to find the pair of factors that when you add give you positive 3. And notice that I have that pair right here. Negative 5 times 8 is negative 40, but if we take negative 5 and add 8 to it, we do get a positive 3. So our 2 factors are positive 8 and negative 5, so that's what's going to go in our binomial groups. We've got minus 5 and positive 8. In the first term in each group, we've got our y's, and that is our factored answer for that problem. Note, sign is very important. Okay, so let's look at this example. Now, this example demonstrates a couple of important things. The first thing is, notice that all of the problems that we've been factoring for these trinomials have been in descending power order, where you want the trinomial to write the term with the highest variable power first and then go in descending order. Okay, we're going to rearrange this and put it in descending power order as well, because in order for this factoring technique to work, you want descending power order. So carry the sign. The highest power is x cubed, so we're going to write that first, negative x cubed. Then we want to write our next highest power second, so we've got plus 4x squared. And then lastly, we have a positive 32x. So that's the first thing that this problem demonstrates. You want descending power order. The second thing that you want, which has been mentioned with earlier factoring techniques, but not necessarily for this one, is your first step for any factoring problem, okay, regardless of the technique you're using, is you want to always look and see if you can factor out a greatest common factor first before you do anything else. So here, notice that the first term, when we rewrote that in descending power order, was a negative term. And our goal is to always have our first term be positive. So you know you want to factor out a negative something. Now, in addition to that, notice that there are x's in all three of those terms, minimum of 1, so we're going to pull out a negative x. So that's going to remove an x from each term and change the sign of each term. So negative x squared is now going to be positive. I'm sorry, negative x cubed is now going to be positive, and we're only going to have 2 x's, or x squared, left in the group because we pulled out an x. Okay? Positive 4 divided by negative, or negative 1, is the same as minus 4. It changes the sign. We had 2 x's, we pulled out 1, we're left with an x. And out of this last term, we pulled the x out and we changed the sign. 32 divided by negative 1 is negative 32, but the x is gone. Okay, now just like with factoring by grouping, after you factor out a greatest common factor, you then want to ask yourself, is there something more I can do with the group that's left? Okay, so I'm just going to pull this out to the side and now look at my group, x squared minus 4x minus 32. Note that this is one of the simpler trinomials, x squared plus bx plus c. So I'm interested here, and I'm going to bring this up here, I'm interested in factors of my last term, so factors of negative 32, that when I add them give me negative 4. (32) will break down a variety of ways. One way is some combination of 8 and 4. And I can see that if I can get the signs to work out, there is a way to combine 8 and 4 to get an answer of 4. Okay? Now the only way to do that is if the 8 was negative and the 4 was positive. So you want to check, is negative 8 times 4 negative 32? And the answer is yes. Is negative 8 plus 4 negative 4? And the answer to that also is yes. So coming down here then, once you find those factors for these x squared plus bx plus c trinomials, those two factors just go into the last position of each group. Then the breakdown of your x squared is just x times x, or x in each group, and that is going to replace this piece. So we've got x minus 8 and x plus 4. And then don't forget your first greatest common factor that you factored out in your first step. That also has to multiply onto those groups. And that is your problem in complete factored form. This is the end of Module 11, Section 6.2 material. You now should complete the homework for Section 6.2 found in my Math Lab. When you have successfully completed the above homework, proceed to the video for Module 11, Section 6.4.